Welcome everyone. Today we have our another new episode and we will discuss on advanced manufacturing. We have our world famous speaker, Mr. Rob Enderle. Mr. Rob, what you want to discuss about advanced manufacturing? For us, especially Asia Pacific, advanced manufacturing very important. Example China, India, Japan, here in Bangladesh or Pakistan, Indonesia, everyone trying to develop a ecosystem for advanced manufacturing. What is your advice? How we can develop better strategy, better policy for advanced manufacturing?
So the thing that's changed in the last few years in terms of manufacturing is the ability to simulate the manufacturing floor. Um, that's primarily been driven by NVIDIA with their Omniverse product, but that allows you to build a factory virtually, fully test it, assure the lines, assure the automation, assure the safety of any human workers that you have in the space, and also assure that the manufacturing facility is going to be flexible enough for your needs over the next 5, 10, 15 years. Because what can happen is that you can build a manufacturing plant for a select number of lines, but those lines may only have a life in market of 3 or 4 years, and then the manufacturing facility has to be repurposed. And if the cost of repurposing the manufacturing facility is too high, then it's going to be shut down and a new manufacturing facility will have to be built. But if you can build something that is somewhat flexible, then you can, at a much lower cost, pivot to the new opportunities. And you can do all of this in virtual reality in the metaverse. And by so doing, when you finally do start to build the site, many of the things that create cost overruns in building a manufacturing plant have been addressed, and so you're much better able to hold to the initial build cost. You typically don't get as many, if any, cost overruns. And once the building's built, if you twinned the metaverse version of the plant site, the Omniverse version of the plant site, to the real plant site, you can use the metaverse version as a way to manage the plant site, getting a rendered view of whatever is going on based on what the cameras are capturing. And overlaying artificial intelligence, you can put in place things that might catch and remove any safety hazards that emerge during the time the plant's in operation, or catch inefficiencies. And you can still do simulation for it. So for instance, when it comes time to change the lines or change a line, you can change the line in simulation first, vet the materials flow, vet the employees, vet the automated aspects of the plant. And then when it comes time to actually swap the lines, you're prepared to go in the most efficient, most cost-effective way possible. So that's applied metaverse technology with an AI overlay for ongoing management. And by the way, you use the artificial intelligence during the simulation phase to simulate what people are going to do, what the robots are going to do, and the rest. BMW is just pretty close to completing a major factory in Germany that was created through simulation, highly automated, with robots moving materials around the floor instead of people. And the end result was incredibly favorable. They were able to spin the plant up much more quickly, and it's argued that the plant is far more efficient as a result of all that simulated experience they gained before building the plant. I think that's pretty good for an opening. I'll now pass over to David, who's now joined us, and I'll let him, and we'll find out whether his microphone's working today. Hey, Dave.
Oh, come on now. My microphone was working before. It's the internet that's the problem.
True.
And hopefully it is better. Spectrum actually knocked the whole neighborhood down for maintenance yesterday for 2 hours, which was a lot of fun. They just don't get it. Advanced manufacturing to me is a really interesting topic, and it goes back for decades and decades. And Industry 4.0 is actually trying to redefine part of advanced manufacturing as well, too. I've had the privilege of serving on some other organizations, and one of them was we set up something called the Council Consortia. And the consortia, the National Center for Manufacturing Science, NCMS, was one of the groups on there, and they were trying to push the forefront of advanced manufacturing. And Rob's touched on many of the basics of going forward. But what we're also seeing, though, is with the changing world environment, with logistics being totally out of whack now, and a shift in the basis of manufacturing from mega size, lowest cost possible into one that says, how do I manage my risk? What do I manufacture locally? What can I do others? How can we look at national security interest? How can we look at trade barriers? How can we look at the tremendous disruptions to the global supply chain? That is dramatically changing the face of advanced manufacturing today and will continue to do so. The average time it takes up to spin up a advanced manufacturing facility, qualify it, and get good yield out of it is measured in years, not months. And you need to understand that as we're going through it. And things like the pandemic, remote work, and the whole trends for that are also forcing people doing manufacturing to reconfigure the manufacturing flow and management. And of course, the environmental impact of the manufacturing process and its byproducts is causing a lot of advanced manufacturing today to rethink their processing, trying to become greener and to get to net zero and move back that way. And so many of the advanced manufacturing companies are beginning to look at things like Industry 4.0 to work through them. And we see some of them, there's something called the Global Lighthouse Network, which is a collaboration between World Economic Forum and McKinsey, trying to push new standards in advanced manufacturing and how to take advantage of the new increased digitalization that we're seeing in advanced manufacturing. And how do you create a roadmap in the way to do it? Because that just isn't there. So we're seeing more and more companies go there. We're seeing them in sustainability, productivity, agility. Agility is a big part of advanced manufacturing, speed to market, and others. So that's part of where we're headed with this, Sharif, and part of what we need to do to leverage the future of advanced manufacturing and create this one. Advanced manufacturing, though, is not a single model. It's not a single roadmap. It will vary by industries. It will vary by geographical considerations. And if we do not understand that, it will cause tremendous other difficulties there. But Sharif, let me stop there for a minute and let me give it back to you and Rob, and I'll come back with some more comments.
Thank you, Mr. Robin Dudley. We want to learn more about research and innovation for advanced manufacturing projects. So, how does it work? What happened in the California or Silicon Valley, or how USA focus on advanced manufacturing industry?
Well, recognize that manufacturing in Silicon Valley is has been in decline for years. The fabs that Intel had, most of the capacity has moved out to other states, Oregon, New Mexico, Texas. So there isn't a ton of manufacturing in the sun. It's just too costly, and I think it points to when you're placing a plant. Originally, I mean, when we go back a couple hundred years, you place the plant near power. If it was hydropower that you needed, you place the plant near the water. If it was electrical power that you needed, you place the plant near a generator, and it was transport that was the issue. In other words, for logistics, both in and out, and you place it near a large railroad depot or near a coast where you had access, coast or waterway, where you had access to transport over water. Now it's we're back to, I think, looking for talent. We just had what appears to be a failure with TSMC trying to build a huge plant in the United States, and they can't get people. They can't get people to build the plant. Enough people to build the plant. They can't get enough people to operate the plant. And that's showcasing that we're back to placing plants perhaps where they can get the staffing needed to operate them. And if we look at the mega data centers that are going up, it's kind of an interesting that they still go towards where power is cheapest because their staffing levels are so low. And I expect that's where manufacturing is going to evolve a bit, because with this next phase of manufacturing, we're going to be moving to move my window so I'm actually looking into the camera. We're going to be really looking at very low, much like data centers are, very low staffing levels. And we're back to power and logistics being the gating factor for the plant site. And perhaps anticipating that would be important. Also, as we look at building manufacturing plants, recycling is becoming an increasing issue for the company. And it's very possible that a manufacturing plant may also be asked to take part in the recycling effort so that the materials removed from recycling are closer to where they're going to be used, reducing the overall recycling costs. Because if you're recycling materials in one geography and then you're having to ship those materials to another geography so they can be reused, that adds to the cost of those materials, which are also already pretty high. Our mining, we can still mine most materials more cheaply than we can recover them through recycling. Yet we want that recycling effort to be profitable, which means we probably are going to need to think about that as we choose plant sites, and we choose what the plants are going to do. So either placing them near recycling plants or building the plant, adding the responsibility of recycling the products the plant builds into the plant's overall design scheme. So as we move through the different phases of manufacturing automation and eventually turn plants into what are basically large-scale 3D printers, the effort's probably going to, in terms of plant placement, are going to have to do a lot with how well that plant can be secured against things like weather, war. We're certainly experiencing going through that kind of a change in Taiwan at the moment, where a lot of manufacturing capacity is being shifted out of Taiwan as a result of the fear of China attacking Taiwan. Kind of learning a bit from what happened in Ukraine and perhaps getting ahead of the curve a bit more than we have been. But those aspects have to be factored into the plant placement and plant design, and we've got to be very careful as we move to these advanced forms of automation that we make sure we assure quality. That was one of the differences I learned after studying the manufacturing plant that Tesla put up, highly automated, and compared the older plants that Mercedes had and the newer plants that Tata had built for Jaguar. At the time I did the review, Jaguar's quality was substantially higher than Tesla's with the same level of automation. Largely because they brought in Germans from hired ex-Mercedes employees to handle quality control. In Japan, when they were having quality problems, they got around the quality problems by having people sign their work. In other words, making individuals responsible for the work and having them sign it, much like what Mercedes does with AMG. And that resulted in a higher level of quality, but you have to focus on quality. The problem with the Tesla plants is they didn't focus on quality. They didn't have a critical mass of people that understood how to build automobiles. And as a result, they were able to bring technology to market that the auto industry was unable to do and do so successfully, but the quality was really poor. And right now, Tesla's quality is still rated below where other cars in its most other cars, there are cars that are below it, but where most other cars in its price range are, because they still haven't really grasped the quality issue, and they're still being accused of covering up quality problems as opposed to addressing them. I think in the last few weeks, there was a report that indicated that when people were complaining about battery problems, Tesla would just kind of shine them on and sweep them underneath the carpet and wouldn't address the underlying problems. And batteries, as we mentioned before with electric cars, are already the car's weakest link, and so not assuring the quality of the batteries can be problematic, and they're not the only ones. We're experiencing issues with LG batteries here in the States and in Europe. They're used in Jaguars, and I know this because I've experienced some of the problems myself. So assuring the quality of the product becomes very important. And as we go back to, I think, a level of vertical integration, because as we start turning plants into more like 3D printers, where increasingly raw materials are coming in, and on one side and finished goods are coming out the other, then the onus to assure the quality of the components will fall more squarely on fewer individuals. And the end result should be the ability to raise quality. But if there's no focus on quality while that's going on, that won't happen, and we'll have additional problems, as Tesla demonstrated. So recognize that the manufacturing is in flux right now. We are looking very differently at how we design the manufacturing plants, how we place the manufacturing plants, how we staff manufacturing plants, and how we automate those plants. And with any manufacturing plant, you really need to design for the world as it will exist 15 years out, because that plant has to remain viable for a long enough period of time to pay back its investment cost. And it's really hard to pay back the investment cost of the manufacturing plant below 15 years. In fact, you really want a plant to be running for 30 years or more. And that means you kind of have to plan for the plant to be operational and effective at least 15 years out, to assure that it has the potential for a 30-year run. Now, be aware that we really don't have a good grasp of what the world's going to look like in 2040 yet, but you still have to build with that in mind. Otherwise, you're likely to have to obsolesce the plant prematurely and write off that cost, which isn't a great career move for whoever's in that decision tree. So in the end, making sure you're designing for the future, making sure that you're putting the plant in a place where you can adequately staff it, or you have a knowledge that you can use an AI component to replace the staff that you can't get and bring the plant up. Assuring logistics, assuring the plant can survive both weather and hostile events, and making sure that your plant can handle not only today's workloads, but workloads 15 years out would be the advice I would provide if somebody was asking me to help them design a plant site. And of course, have the heavy use of the metaverse, and right now NVIDIA's tool Omniverse, to plan the plant and then manage the plant after it's built, because that's proven to significantly reduce the cost of the build and reduce the cost of maintaining and managing the plant once it has built, using BMW as the example. So that's where I am, and I will pass it back to David now.
Rob, I always love your examples and explanations there. Advanced manufacturing is one that is so necessary for us to support our ecosystems, our quality of life. And as we saw during the pandemic, the labor shortages we have. So we're not only seeing the metaverse, as Rob talked about, but a lot of new emphasis on sensors, on robotics, on artificial intelligence, on machine vision, and the artificial intelligence work today in an advanced manufacturing environment. We also know that Rob's used Tesla as an example. The Tesla factory that is down the toll road from me here in Austin is a very interesting example when you go in there. There's a concept in advanced manufacturing called a lights out manufacturing facility. And what a lights out manufacturing facility is a facility with no humans inside of it. It's all run by robots and tools and AI and other stuff like that. That is one of the places where we're seeing more promise of advanced manufacturing going, is eventually to some of these lights out manufacturing facilities where they can work 24 hours a day, 7 days a week, as long as the supply chain logistics can keep up with it. And today, that's where many of the challenges we see in advanced manufacturing are, is getting the necessary parts and pieces there getting the necessary staffing there to be able to achieve it, and being able to do it in a manner where there are quality yields. One of the biggest challenges of advanced manufacturing, particularly when a change is introduced, is working the bugs out, working the process changes out to where you can get an acceptable yield. And for example, in a semiconductor fab, in a semiconductor advanced manufacturing facility, a percentage point on a yield curve translates into millions and millions of dollars. So it's one of the things that is very important to get right as you look at advanced manufacturing. The requirements for advanced manufacturing has changed a lot. It used to be many of the people on a manufacturing line were people who did not have very advanced education. Increasingly with advanced manufacturing, your amount of training, your amount of education is increasing because the complexity of the tools you're using are increasing. And it's becoming more of a technology-driven approach than it is a craftsman-driven approach, which craftsmanship was there a lot. I mean, the question that just got popped up is a good one. What propels it further going forward is a great question. And, design and engineering are already there, but, sensors, science, advanced software engineering, advanced material science engineering, understanding workflow and process flow are all very necessary skills going forward and very necessary to be successful with today's advanced manufacturing environment. The other thing that we see is that Rob often and I often talk about the concept of digital twins. You have the same concept of digital twins in advanced manufacturing. Let's say I have a manufacturing facility here in Austin. I have one in Germany. I have one in Asia, and others. We want to be able to look at each of those manufacturing facilities producing the same type of product and be able to optimize between them. And so these digital twin concepts is a very important one. Plus, as Rob was talking about the metaverse and digital twins, you want to be able to simulate, do your modeling simulation of any changes you make in the manufacturing process and the manufacturing runs before you have to do them in the real world. You want to work out as many problems as possible before you start wasting product, wasting supplies, wasting manufacturing time. And this whole concept of a digital modeling simulation of advanced manufacturing operation is really something that is a more recent phenomenon. We did parts of it in the past, but they were limited. But with the tools we have today, we can simulate hundreds of changes, thousands of changes within an hour, and see the results back before we have to go and reprogram robots. So change flows, go change. And those are the changes that we see today that are really important for us going forward. And I hope my internet's fixed. It just flashed on me a couple of times. So Rob, I hope it's there. Let me check my connection and come back. But let me throw it back to you since I see Sharif is not with us.
Yeah, thanks. Yeah, you did break for a second, but it wasn't too bad. You just froze for a second. So looking at the question, one of the interesting parts of the question that came in has to do with integrity. I'm an ex-internal auditor, and as we move to automation, a lot of the controls that automatically prevent against theft potentially get removed. Things like separation of duties, because you just don't have enough people or enough different practice to separate them. One of the concerns I've got as we've moved to full automation, and as David Smith said, lights out manufacturing, is you may only have a handful of people managing the result, and that creates a fairly high potential for self-dealing, for fraud, graft, and some of the issues that you can have when somebody has too much power, but not enough oversight. And so you can put in automated methods to assure integrity, but my view is really integrity should be dealt with in the hiring and oversight process. A lot of what goes on when you're staffing a plant, particularly a new plant, is you're hiring existing talent, you're asking them to move, and then you're putting a bunch of people together that have never worked together before and who you don't really know all that well. And that can be problematic for integrity because we know that people lie about their backgrounds. They're people that cheat in school. So even if their degrees and their background is accurate historically, if they cheated in their past jobs or cheated in school, they don't have the skills that they profess, and they're going to be a problem. And they undoubtedly are going to cheat or create problems for you in the plant. One of the things that Intel in Israel did that I think could be shared as a best practice is rather than importing a bunch of people that were already trained up and going through the cost of requiring them to relocate, Intel instead took a bunch of people that were in the area that had high integrity, that they had low-paying jobs, but they've been able to demonstrate high integrity, a good work ethic, and then trained them into jobs in the plant. And then while they're working in the plant, educated them into higher level jobs and worked them up in the plant. This created loyalty between the worker and Intel. They're not fly-by-night employees. They're there for the long haul. They respect the fact that Intel lifted them up into higher socioeconomic levels, and that reaffirms the loyalty. And the only thing then you have to watch out for psychopaths and sociopaths, which every company has to experience, and being able to weed those kinds of people out of your workforce should have, I think, a higher priority than we placed on it in the past. We're kind of suffering through that here in the States at the moment. But the result of actually grooming your workforce to have decent ethics, to be loyal, I think is worth the effort, particularly as we go through this process of automation, where you're going to have fewer and fewer workers being responsible for more and more things, and your ability to mitigate crimes in the company or overcome just mistakes because they're poorly educated becomes reduced, because fewer people are doing more things, mistakes are going to get bigger. So the end result is if you can better assure your workforce as you're modernizing your plant and assuring that the people that you retain are those that have showcased loyalty, that have showcased a good work ethic, have showcased a sense of work-life balance. Because the other issue you can have is if workers don't have a good work-life balance, they'll have a tendency to burn out. And a loyal worker may become a disloyal worker if you press them too hard to put them in financial distress, which does mean you also need to take a hard look at comp and make sure that your people are earning a living wage. You do not want a large proportion of your employees operating below living wage, because then they're going to be motivated to commit crimes to close the gap. That's often one of the reasons why certain countries have higher levels of graft in government than others, is because they're underpaying their bureaucrats, and the bureaucrats are adjusting their salaries through other means and creating graft and legal problems for the government. So assuring an adequate salary, assuring the employees are taken care of, and assuring a focus on growing the employees inside the firm to a firm loyalty, so the employees don't get a sense that they are the cog in the machine that has really no impact on the company. One other thing that I should point out as best practice is back when I was in IBM, I spent a lot of time trying to understand why IBM nearly failed in the 80s, and wrote one of the definitive reports inside the company as what needed to be done. And one of the things I ran into that the company had forgotten or lost was when Thomas Watson Jr. would go out and visit plant sites, he would randomly visit employees, blind employees, and sit down and meet with them for about 30 minutes. And he would ask them a series of questions having to do with how they fit into the company, and how they understood the company's priorities, objectives, and what they were personally doing to help the company achieve those objectives. And if the employee could answer those questions effectively, all good and fair, and he was off to the next event. But if they couldn't, he'd start hunting managers because he viewed that as the manager's job to make sure the employees were engaged, to understand how important they were to the company. And if they didn't think they were important, that was a serious problem, and it was the manager's failure to address that problem that put them at risk. I should point out, I never found an issue where he'd ever fired an employee that he'd interviewed with, but a lot of anecdotal evidence that there were ex-IBM managers, and by the way, this was during a time when IBM was a full employment company where you were expected to work there for life, and so firing a manager or anybody in the company was problematic and difficult. But you could get removed if your employees were not showcasing the appropriate connection to the firm, and I think that's something that should be encouraged with every firm. That employees should know how they fit within the company. They should know how important their contribution is, and they should know how to mitigate or optimize their behavior to help the company meet its stated goals and objectives. And that includes everything from the product they're building to how employees treat each other. Increasingly, at least here in the United States, one of the things a manufacturing site or any site is expected to do is adhere to the rules surrounding how you treat minorities and women, and making sure that you are not abusing your privileges or your position to take advantage of any disadvantaged group. And even if the group isn't disadvantaged, billing another employee is absolutely unacceptable. One of my experiences in IBM that was very memorable was when we had an employee come forward in fear of his life because he was working for his cousin. His cousin was stealing from the company and had told him that if he ever reported the theft, he was going to kill him. Those kinds of things occur far more regularly in companies, and making sure employees have a safe place to go to report problems is incredibly important, because the problems exist, they won't go away, and the tendency for a lot of firms to try to sweep these problems under the table in order to make them appear to not exist is problematic, because the problem remains. And when an employee goes south, commits suicide, comes into the company to shoot fellow employees or cause harm, that's a major event. And when a major event occurs, there will be an investigation, and the people responsible will be held accountable. And you want to avoid those major events. You want the employees to want to be there. You want them to feel safe while they're working, and you want them to feel like they've got a path to advancement. You don't want employees that are dead-ended, that feel that they're being underpaid and abused. And particularly if you're a non-union shop, if you don't follow that guidance, you will soon become a union shop. The employees will organize. And if you've ever been through a union organizing event, and I have been through several times, I was trained to be a union breaker, which is kind of problematic, because typically, if you really want to be a union breaker, you'd operate far sooner and focus on employee satisfaction, growth, and advancement, as opposed to how we were typically focused, which was to disparage the union, to break apart the working groups that were creating the union, and to get rid of, while it was legal, the employees that were fermenting rebellion. That to me, and by the way, it was not always successful going that particular route. And when you do those kinds of things, you create a huge barrier of trust between the employees and the firm. They can cause other problems later on in their careers and your operation with them. So in the end, a big deal about the factories of the future is, one, they're going to have a lot less people, but number two, you're going to need to treat those people far better than a lot of these manufacturing workers are currently being treated, and you're going to have to make sure that they're motivated to operate ethically and correctly, and you won't be able to rely as well on things like internal audit to catch them, because they can do an awful lot of damage in a far faster time than an auditor is going to catch them. The thing about auditors is, and as I say, I was one, is we are infrequent. We don't look at everybody. We look at things in terms of samples, and we can't catch everything. Now, be aware that internal audit is undoubtedly going to be automated. And as soon as we move to automated internal audit, then sample sizes can go to 100%, and people that have been committing crimes will get caught almost immediately. And so the really kind of motivating those people to get out of existing sites and companies before this happens would be a way to help mitigate the problem before it becomes a crisis. And when I say crisis, when you find somebody that's been stealing from the company over a long period of time, where the damage is in 7 figures or more, that's a board level event. And when you have board level events, a lot of heads will tend to roll, and you want to avoid those at any cost. So the best path is to treat the employees well, really take an effort to monitor and moderate the employees' work so they have good work-life balance, so not burning out, and making sure that the compensation is appropriate for the level of responsibility so they are not motivated to create problems or steal from the firm. And finally, really ensuring the growth and career of the employee so that they don't feel dead-ended and that doesn't become a problem. And I'll pass back to David.
Rob, you're getting so right. And I see that Sharif is not back with us either. The HR problems can be significant, particularly in that I love some of the organizations like IBM and some of their divisions where they have dual tracks, where they have a management track, they have a technical engineering track, they have a manufacturing science track, and others like that, which really help recognize the importance of the human capital involved with each of those. Um, Rob, I would go crazy sitting in front of your microphone all day with it changing colors. But it's so cute. Uh, no, it's fine. It's it's one of those manufacturing things that we have to really work on, because one of the questions that Sharif always asks is, what is it impacting the developing world? What is this impacting universities and others like that? And advanced manufacturing tends to be the execution side of the work that's done in advanced science. It tends to be the execution side of what is done as part of the entrepreneurial journey to get products out. And I used to say that most manufacturing is the same. I've come in my older age to understand it's not, and that we have to understand that the word manufacturing is not one size fits all. And I can manufacture in a software company differently than I can manufacture in a semiconductor company or a electronics company. I manufacture different building airplanes than I do manufacturing steel. But each of those have some commonalities in that you have to have a defined process flow. You have to have KPIs, key process areas that you are tracking and being able to make allowances against. You also need to have the ability to understand that today you live in a world where you're dealing with a supply chain and other suppliers and other partners that in most of these industries are well outside your factory manufacturing floor, and that you need to make allowances for that within your advanced manufacturing operation. I can tell you, I've been in some very advanced manufacturing operations where part of the manufacturing process, even on the floor, were not managed by the company that built the manufacturing floor, that builds the products, but were managed by their partners, particularly very specialized operations on very specialized equipment. You'd often have employees from the company supplying it come in and be part of your manufacturing operation. So Rob mentioned the whole human capital side, the human resource side. It gets much more complex when you begin to see that type of interaction in an advanced manufacturing facility as well, and how that can go. Now, we also talked about some of the uncertainties, others like the supply chain and labor shortages. We're also in a time right now where there's some pretty uncertain economic environments going forward. And the decisions to build advanced manufacturing facilities really have to take into account a fairly rigorous forecast of what is the future economic environment. What are the return on investment criteria? What type of yield do you need to have to come out? What type of process flow? And we're getting better, particularly with our modeling simulation going there. But, the leaders today in advanced manufacturing really need to look at how to leverage these digital technologies like we're talking about, how to leverage the concept of the digital twins, how to leverage the context of real-time feedback during the manufacturing process, of tying that into automation tools and AI that can react to that real-time feedback, of beginning to look at how the broader range of digital technology, the machine vision, and even the advanced robotics can play into it. They also, in advanced manufacturing, should spend time. And this is probably one of the places that the pandemic has helped force us into making these decisions, is we need to look at the strategies for the future of work and how these new strategies for the future of work are changing most industries today. Um, there are emerging now new models for supply chain resiliency. Uh, and that is an area that advanced manufacturing has to build upon, have to build upon for it to be there. And, you have to see this implemented in a form of agility. Uh, it used to be you had one prime supplier and maybe a backup. Well, now you have to not only look at backups, but you have to look at geographical diversity. Is if I cannot get products from one part of the world to another, is that a good supply chain for my advanced manufacturing? For example, if you were to go today and look down at the Panama Canal, there's hundreds of ships backed up on either side of it. And actually the heat wave and the drought is causing problems in the Panama Canal as well. So if I'm trying to ship necessary supply chain parts for my advanced manufacturing facility and it's going through the Panama Canal, and that's my only source, I have big problems right now. Same thing we saw during the pandemic when, for example, off the coast of California at the port of LA, there were hundreds and hundreds of ships just anchored out there because there was not staff at the port of Los Angeles to unload the cargo they had there. And there were not enough truckers there to take it off of the dock and move it to its intended destination. So those are some of the supply chain things that you have to do. Another thing you have to do is really, and Rob, it does such an excellent job of hitting this, is you have to look at a really a broad range of talent management strategies today. The amount of voluntary exits, are people quitting their jobs, is actually increasing, particularly in some of the manufacturing domains, because you see, and with a tight labor market and with a workforce churn that's happening right now, this whole new approach to human capital and the talent models needs to be a top priority for people in it. And even though we see technology coming in to help, we see a lot of job openings there. There is still a lot of need for there. And one of the statistics that I saw in a recent study from Deloitte is that voluntary separations, people choosing to leave, continue to outnumber layoffs and discharges and reductions in force and things, which is really reducing a lot of the operating efficiency and really the company's ability to turn out a quality product at a decent margin. And so you're having to do that. The next one really is, again, going back to that slide, supply chain. There are not great solutions to that, but those are things that really need to be adjusted and take part. And one of them that is just so big right now is that social responsibility is key to working there and key for monitoring the future going there. And that many regulatory agencies are moving to more and more disclosures for required metrics in manufacturing based around social responsibility. And finally, we've heard of smart cities, there's smart manufacturing as well too. And many manufacturers are making fairly large investments in underlying the technology foundation for the future of smart manufacturing, smart factories. And as Rob said earlier, they're developing metaverse platforms for their products and services that will let them begin to test it more, do more. But you can see that this whole smart manufacturing, advanced manufacturing, is one that has multiple elements in it and multiple in and out points, and is not a simple model. Those of you who've listened to me on this program often know I will come back and talk about everything today is a system of systems. This is never as much true as it is in advanced manufacturing, smart manufacturing. And so any change you do within this advanced manufacturing ecosystem, within the factories, within the supply chain, within the distribution, within the management, all affect the others. And you have to have the appropriate education in place to understand that. If you're in a factory that is changing from a non-digital factory, yes, I know some of those still exist, into a digital factory, and then to a AI-driven digital factory, the changes are immense. I'm remembered of a visit to Brazil, actually a couple of decades ago now, where I walked into an aircraft manufacturing plant there, and it took me back to my youth. I grew up with my grandfather and my mother working in the aircraft manufacturing industry in Dallas, Fort Worth. And you would walk in there and you'd see big jigs of men all over them. You could smell hydraulic fluid everywhere. And it was a mechanical process. Then I walked into like a Boeing aircraft facility. You see robots everywhere, not many people. And you don't smell hydraulic fluid. You don't get the other sense of the old manufacturing process. When I walked into the factory in Brazil, it was the old way. And now they're transitioning to this new digital advanced manufacturing process, which causes everyone to have to learn and for everyone to have to adapt to it. And those pieces to be, it's something that's hard to do, but it's necessary. These changes are always necessary, but in many instances, they're not sufficient to be able to do everything you need to do to have the yield and the impact you want to do. So Rob, coming back to us, I see Sharif still has not rejoined us. At the top of the hour, I have to be on another call. And I don't have the meeting invite I see for that yet, which I thought I would have by now. So I'm going to have to very shortly go and figure out what's happening to that meeting and what we can do there. But last thing there is, I just want to respond to one other thing. Daniel asked about makerspace tools and things. Well, makerspace I love. And I love going in and using the tools there. That's where I do my very limited 3D printing today, even though the makerspace in Austin just closed. And we're all mourning it. But advanced manufacturing, almost by definition, has to be done at scale. And a makerspace really doesn't give you scale. It gives you a great place to prototype and to experiment, but it doesn't take you to scaling. And the only way you will make a significant return on investment in manufacturing is to get to scale and to maintain all the elements, particularly the supply chain elements. So, Daniel, I love your thought here, but it doesn't give you the capacity that's needed to have a broad impact. Can I do something localized? Yes, but it doesn't give you the capacity. So, Daniel, that's my thoughts to your question. Rob, back to you.
Thanks. I'm gonna I'll take the question as well and take a little bit of a different angle. David's absolutely right. In terms of scale, that's the whole point of advanced manufacturing. You're talking about build rates in the tens of thousands of units, and that just isn't where the makerspace is. However, when you're building everything the same, remember the way back when we first automated manufacturing of the Model T, everybody could have any color they wanted and any feature they wanted, as long as it was the feature that was in the cars and the color was black. You didn't get any customization. And where the makerspace could come in, is in terms of customization, in terms of being able to provide parts, accessories, things that could go in the car that would allow somebody to uniquely customize them. And they could be installed prior to the dealer getting the automobile, or if the automobile or product was highly modular, they could be attached by the end user after the product was received. So picture a television set. Let's say you didn't really like the metal framing that was on it, and you wanted a more interesting science fiction or rural or organic kind of frame around the TV set. That's an ideal job for a makerspace individual who could then provide that and then have them have their product and the television arrive at the same location at the same time, and the installer attaches the two together, and the user gets a highly customized set, while the economies of scale to create the set in the first place weren't damaged at all. And so I think where the makerspace plays, other than just prototyping, which is exactly where it plays today, when you're creating or conceptualizing a product, if you're not conceptualizing it in the metaverse first, and you need a physical prototype, makers can play in that. In fact, they're automotive. We've got a facility outside of Los Angeles out here, an automotive facility. It's a small group, and all they do is build prototype cars. Fascinating stuff. One of the cars I recently saw was framed in carbon fiber tubes, designed in the metaverse, framed in carbon fiber tubes, and largely 3D printed, which makes it a makerspace offering. And so customization, short run, highly customized products, those all fit within the makerspace envelope, and could play a major role in kind of mitigating the one size fits all thing that we get when we have high automation. I mean, if you look at Teslas, you don't really get a whole lot of choices in those cars in terms of design, layout, or interior. There is the equivalent of another company, more of a makerspace kind of company, much like AMG used to be for Mercedes. I can't think of their name right now. But they work separate from Tesla, and they provide Tesla owners with custom aero, custom interior pieces, a way to modify their vehicles to make them more unique to the individuals. And a lot of us like to have that custom. It's not everybody, but a lot of people like to have that customized experience when they have a car, or if they have furniture, or if they have an appliance in the house. They want something that's going to work with their interior design. And a lot of those tastes are very different. And here, makerspace could step in and address one of the shortcomings with large scale automation and manufacturing, which is a lack of variety. by providing that variety after the fact. Even in personal computers, there is an outfit in, I think they're out of Seattle, that builds a custom wraps for laptops and gaming systems that you can buy, and you can customize the look of your laptop, and just something that the PC OEMs have tried in the past, but just weren't able to do very well, largely because if somebody then returns the laptop, it becomes unsellable because how it's been customized isn't attractive to somebody else. But if these things are applied after the purchase, then you get a customer say, granted, you have an issue as a user returning it after these things are done, but assuming you like the product and then you apply the veneer to the product to make it yours, then you get that level of customization that you can't get from Dell, HP, or Lenovo. So there is a play for the makerspace, but I think it has to do with customization, accessories, and short-run offerings. We see that today with the 3D printers. A lot of the 3D printing work is to build parts that are either unique or that for things that are long out of warranty and where the manufacturer is no longer supporting. The manufacturer might not even be around. You want to get a part for a Studebaker. Good luck with that. You need to go to somebody that is kind of in the makerspace to 3D print you a part using metal sintering or using one of the new 3D metal printers. And then they'll make you a part that's identical to the part, assuming you've got schematics or you've got a part for them to model. And a lot of those parts exist on the web that you can buy in digital form, and then they can make you that part, and you're good to go. Having gone down the path of resto modding a 1970 automobile, you really get to appreciate some of these folks that can build these customized parts, because the manufacturer isn't building parts for them anymore. So that's really where I think the makerspace could go. And as we advance into this next age of manufacturing, the company that's able to figure out how to provide the economies of scale that you get by building a lot of things that are very similar, but providing the customization that the users want by providing the option of them being able to highly customize the end product as they desire to work, for wherever they wanted to work, in their office, in their home, or on the road, I think would create a unique blend and opportunity. It also, by the way, focuses on where a lot of problems often exist in the manufacturing space. When plants are built, often one of the problems is there isn't enough discussion with either the companies that need this manufacturing capacity to be built, assuming it's not a vertically integrated firm where the company is building its own manufacturing capacity. I'm talking about a lot of what's happened in the last few decades, where we've decoupled manufacturing from the companies that sell the product, and the products are built by assembling, often in a contracted site, the components which are also subcontracted out in other plants. And a lot of the problems result is that really nobody's collectively talking to the customer, and nobody's collectively talking to whoever carries the brand, and that's where you tend to get a lot of breakage. And so creating communication links that loop in the users, that loop in the customers and the logistics chain, so everybody kind of knows what the expectations are surrounding the product, can do a lot to increase the perceived quality of the offering that comes out the back end, and better assure that the customer, all of the customers in the supply chain, are receiving what it is they want and aren't scratching their head wondering, well, what broke down, because what I got wasn't exactly what I wanted. And it does force us, particularly as we move to generative AI and 3D printing, to better articulate what it is we want, because a lot of the breakdown isn't necessarily on the manufacturing side. It's on the customer side, who hasn't really learned how to articulate what it is they want, and they're asking the manufacturing side to kind of fill the gaps, which can be done if the manufacturing side fully understands the industry and understands the customer base, because they can fill those gaps. But in a lot of cases, they can't. And some of these sites that build parts for aerospace and automotive and appliances, they're just not going to have the deep insights into the end users that a vertically integrated company is going to have, and making sure that those gaps are filled is going to help prevent the kinds of problems you have when parts come out that don't exactly meet the spec, or falls short of the spec that the people that define the end product set, or that the user expected out of the back end. And so one of the issues we really do need to address as we go to high automation is communication and collaboration, because those things got badly broken during the pandemic. And I'm not seeing as much recovery as I'd hoped months after the pandemic is largely settled. And the end result is I think we're going to continue to get a disconnect between products coming to market and the customers that want to buy them. And closing those disconnects will better ensure we don't have the kinds of inventory problems that we're experiencing as we now go into the fourth quarter, when we're seeing an uptick in inventories and a potential downtick in sales, not necessarily due to a mismatch of customers and product necessarily, in this case due to folks reaching their credit limits on their credit cards, which are going to do some interesting things with regard to inflation. That's a whole different program. So in the end, are really thinking through the logistics and making sure that customers can get what it is they want, and then looping in makers into the process to really close those gaps in customization that remain open. A lot of the issues, particularly in the automotive market right now that I'm seeing, have to do with the fact that people are just aren't able to get the options they want on the cars that they've selected, and that's resulting in unsold vehicles. And moving to a more modular architecture and allowing the makers to fill those gaps, I think would do a lot to overcome the excessive inventory problem we're currently seeing, as of course would lower interest rates so more people could afford the vehicle. So in the end, your question was well taken. David's response was correct in terms of volume. I'm only adding that the makerspace could address one of the critical problems with regard to these high volume manufacturing sites, and that's customization and better meeting the needs of individual customers. And David's still with us. David, do you want to make some final comments before we wrap?
Well, I really need to jump. I'm still waiting to get the last thing in, so it bought me a minute or two. But no, advanced manufacturing, like I said, is a complex system, and one that has to have complex system approaches to solve all of it. Even though I love the adage, keep it simple. But in advanced digital manufacturing, with the interaction of all the systems and the interaction of human capital in a global environment, it's just really hard to do that. The environment is such that it's one that we need to be conscious of. And Rob, I wish I had the number on top of my head, but I think this is like the 976th or 977th one of these for Sharif. And I really hope that the people listening to this advanced manufacturing one understands that this is necessary, but the solutions today are not sufficient to do this well globally. So, Rob, that's my concluding remarks.
All right, I think that wraps for us. We're both gonna drop because I've got other things I have to do today as well, and we'll hope that Sharif can come in a few moments and shut down the event.
Thank y'all.
Thanks everyone, and until next time.